Welcome back to All This Math. This is Professor Parker. I got my Cheney University paraphernalia on today, right? I really like this sweatshirt. You know what I'm saying? It's like two-tone, you know, like a two-tone do-rag from back in the day that some of us used to wear, right? A brother that actually went to Lincoln, he's a Lincoln alum. I don't remember his name, but he gave out a bunch of these on our campus. He makes them for different HBCUs, and he's got a company called Thorough Threads. I believe the name of his company is Thorough Threads. So go check out his company on Instagram at Thorough Threads. I think that's the name too. But, you know, maybe do a Google search or something. But, you know, like I said, he's got some for Lincoln. He made some for some other institutions as well. But, you know, go check out his work. Support a black business, right? Also, shout out to Lincoln. Shout out to Lincoln. Yeah, shout out to Lincoln. It's an HBCU. I do have a degree from Lincoln. I got a lot of love from Lincoln. But I was also going to say shout out to Cheney University, where I currently am employed, where I teach at. I teach math methods courses there. So shout out to Cheney, the first historically black college or institution, founded in 1837 as the Institute for Colored Youth in South Philly. A lot of people from Lincoln would say that it's not the first. I respect their argument, right? I respect their argument, because apparently Lincoln was the first historically black college to offer college degrees, right? So I get it. But, you know, I don't really have a dog in that fight. My undergrad was at Morgan State, right? And we weren't founded until 1867. But anyway, today we're going to do some factoring using the D.O.TS method. D.O.TS is an acronym, stands for difference of two squares. The difference of two squares. The difference of two squares, right? Now, normally you wouldn't be told up front what type of factoring you're going to have to do, right? It's your responsibility to be able to examine an expression, an algebraic expression with variables, exponents, numbers, plus signs, minus signs, whatever, and then be able to identify what method of factoring you're going to have to use. And there are multiple methods of factoring that you would apply based upon what the expression looks like. So this is a binomial, right? So when we deal with binomials, you can either take out a GCF first, or you can take out a GCF out of anything if it's available, right? Or it could be a sum or a difference of cubes, or it could be a difference of two squares. This is not a sum or difference of cubes because, as you see, our exponent is a 2, not a 3, right? Or a larger cube. Also, how do I know this is a difference of two squares? Because there's a subtraction sign. That's where the difference part comes into play. Also, you got a perfect square here. 36 is a perfect square. Make sure you know your perfect squares by memory, right? 36 is one of the perfect squares because a whole number times itself can equal 36. In this case, 6. 6 times 6 is 36. So that's how we know that 36 is a perfect square. Also, 4x squared is a perfect square because the 4, again, is also a perfect square, similar to 36 because 2 times 2 is equal to 4. X squared is a perfect square because it's a variable that has an even numbered exponent. So make sure you put that in your notes. Anytime you have a variable with an even numbered exponent, that variable or that variable term is a perfect square, right? X to the second, X to the fourth, X to the sixth, X to the 20th, X to the 50th, X to the 100th, X to the 1 millionth. It don't matter. As long as your exponent is an even number, that variable term is a perfect square. Memorize that. All right. Now, how do I factor this? Now, with these, right, what I always tell people is you should always look for a GCF first, right? You don't have to, but I recommend you do it. I think it makes the work able to be done more efficiently. So look for the GCF. I see a 4x squared and a negative 36. So what's the biggest factor that those two terms have in common? Out of 4 and 36 is 4, because I can do 4 divided by 4. I can do 36 divided by 4. So 4 is my GCF. So watch how I rewrite this. I'm going to write a 4 outside, and then I'm going to put a set of parentheses, and then I'm going to divide each of these terms by 4. So I'm going to do 4x squared divided by 4. The 4's cancel out, leaving me with just x squared. And then I'm going to do negative 36 divided by 4, which is negative 9, because a negative divided by a positive equals a negative. So this is going to be x squared minus 9. Now, initially, this was already a difference of two squares. But now, since I've factored out the GCF, now I still have another difference of two squares. And you're going to see that a lot. So you got to know what to do when you see that. So now this is a difference of two squares because that's a perfect square. Exponent is even. And that's a perfect square because 3 times 3 is 9. So then you bring the 4 down. Don't forget about the 4. Write your two sets of parentheses, right? Write your two sets of parentheses. Take the square roots of each of these. Take the square root of this, square root of that. Square root of x squared goes in the first spots. Square root of 9 goes in the second spots, or the last spots if you're thinking about FOIL, right? Make 1 plus, make 1 minus. It don't matter. You could have put the minus sign first and the plus sign second. It don't matter. As long as you got one of each, that's all that matters. You just need one of each, right? And this is our final answer. This is our final answer, right? But let me show you something. Let me show you what would have happened, because in math, we got options. There will never be only one way to do a problem. In math, we got options. You should embrace the options. Embrace the options, right? It's good to have options, right? What if I didn't pull the GCF out? Because I ain't had to pull the GCF out. I just felt like doing it. But what if I ain't feel like doing it, right? What if I felt like doing it another way? What if I felt like going straight into using the dots factoring method? Watch this. Because that is a perfect square, this whole term, and that's a perfect square like we already talked about. So watch, what if I do it like this? I do my 2 sets of parentheses, right? I take the square root of 4x squared. The square root of 4 is 2. The square root of x squared is x. I put the 2 with the x, I got 2x. So now I got 2x, I put the 2x right here, and I put the 2x right here. So whatever you do, when you're using this method, you take the square root of the first term, and you put that term in the first spots inside the parentheses. The first spots inside the parentheses. The first spots inside the parentheses. Then you do the same thing for the second term. Take the square root of the second term. The square root of 36 is 36. Now I know this is a minus sign right here, but for these purposes, we're gonna treat it like it's a positive 36, even though there's a minus sign right there. Just for this, we're gonna treat it like it's a positive 36. So the square root of 36 is 6. Then we take the 6 and we put it here and we put it here. Put 1 plus and 1 minus. Now, somebody might do this and think, okay, I'm done, but they're not. You see what I told you? I told you earlier, I said you can either take the GCF out up front or you take the GCF out later. But if there's a GCF, it's gonna have to be pulled out at some point. Because look at these binomials, right? 2x plus 6. What's the greatest common factor of 2 and 6? It's 2, right? So you gotta pull that 2 out, right? The same thing with here. Even though there's a minus sign, the GCF is still 2. So we got a 2, and then 2x divided by 2 is x, right there. 6 divided by 2 is 3, right there, and it's positive. Then we go over here with it. Again, this has a GCF of 2 also. So you're gonna write another 2, and then parentheses. 2x divided by 2 is x. Negative 6 divided by 2 is negative 3. Now that is completely factored, right? Because I can't break down x minus 3 no more. I can't break down x plus 3 no more. I can't do that. But what I can do is I can combine these 2's, right? 2 times 2. I'm not adding the 2's, I'm not dividing the 2's, I'm multiplying the 2's because this is a multiplication expression. 2 times this times 2 times this. I can combine the 2's and I'm gonna get 4 times the quantity x plus 3 times the quantity x minus 3. And ain't that what I had up here? So this is why it's good to understand options and be able to approach problems in different ways. So that way you can see, and it's also a way of checking your work because we just did this problem 2 different ways and we got the same answer. And the 2 different ways we did it were both mathematically correct. So it's good to have options. Like in this option, I pulled the GCF out up front, right? And then I used the dots method. In this option, I went straight to the dots method. Straight to the dots method, I got this, right? These 2 binomials. Then I pulled the GCF out of each of them. I pulled the 2 out of this one, and I pulled the 2 out of this one. And then I just combined the 2's through multiplication. Got 4 times quantity x plus 3 times quantity x minus 3. Yeah, it's a quantity. That's another thing. When you read these problems out loud, don't say the word parentheses. That's unsophisticated. Don't do that. Don't say the word parentheses. This is a quantity. The quantity of x plus 3 times the quantity of x minus 3. All right? All right, so that's the final answer for this one. All right? Final answer for this one, we got that. Or we got this, which is the same thing. We got it 2 different ways. Now let's slide over here. Now with this one, we don't have the option that we had with this one of going straight into the difference of 2 squares because 3 is not a perfect square and 147 is not a perfect square. So we don't have them type of options. Sometimes we do have those options. Sometimes we do not have those options. All right. But we do have a GCF. Now, you got to just know a little bit about numbers. You got to have some number fluency in order to notice that we have a GCF because you would have to know that. And here's the thing, right? When you do enough of these problems, that's why practice is so key. And at the end of every one of these videos, I always tell you, go get some practice. Because when you have practice, you develop mathematical muscle memory. And when you start to develop that muscle memory, you start to recognize that, all right, well, if this is a binomial and I'm trying to factor, I know that I could use the dots method, or it could be a difference of 2 squares. I see that this is a y squared, so what if I got rid of this 3? what would I have to do? I would divide by 3 to get rid of that and to turn it into a 1. But what if I divided this by 3? What would happen? You just start to experiment and start to make certain moves, right? Now, what's going to happen when I pull this 3 out? I'm going to have a GCF of 3. Then I do 3y squared divided by 3. Leaves me with y squared. 147 divided by 3 is 49. And when you see that, you get a little happy because you know that 49 is a perfect square, right? Because 147 divided by 3 is 49, because 49 times 3 is 147. So now I got my GCF of 3 outside, and this is a difference of 2 squares. Y squared is perfect, 49 is perfect, and they got a minus sign in between. So it fits the criteria. So now I can factor this part like it's a difference of 2 squares. There we go. And we all done. I took the square root of y squared, which is y. It goes in the first spots. I took the square root of 49. Again, I treat it like a positive. Treat it like a positive, not a negative. Because if I take the square root of negative 49, I'm going to have to deal with imaginary numbers. And we're not getting into all that with these problems. We don't need to, right? So square root of 49 is 7. Put the 7 here and the 7 there. Make one positive, make one negative. And if I was to multiply all this out, I guarantee you, I would get what I started with. And that's how we check it. All right? So just a little bit about how to factor expressions with the DOTS method. But again, like I said, go get some practice. These problems get easier when you get practice. Don't just watch a video and be like, okay, oh, I know it now, I'm cool. Nah, you're not cool. You need to go get practice, right? That's how you really learn math. The first step is just getting help and just, watching somebody else do it and taking some notes. That's only the beginning. Now you got to actually go get your hands dirty and go do some work, make some mistakes. Learn from those mistakes, and then remember how not to do it, right? You got to get the practice, though. Don't evade the practice. So many people and so many students would be great at math if they would just practice. It's a lot like sports. A lot of people would be better at sports if they would just practice, but they don't want to practice. So if you want to be great at this, you want this to become easy, you got to go get some practice, all right? So, again, shout out to Cheney University, and go get some practice. Ask your teacher for some practice problems. Ask your professor for some practice problems, or just go online and look up examples of factoring expression using when you have a difference of 2 squares. Just do an online search of that and see what comes up and go get some practice. All right, I'll see y'all on the next video. Peace.